Okay, we're ready to work some examples. I'm not really sure why this says example 5. From what I can understand, we haven't worked any examples yet, so if you want to cross that out on your notes and put a 1, that would probably be a good idea. And so let's look at this function, y equals 1/2 tangent of 1/4 x plus pi over 2. Now, you can find the information in whatever order that you want. Usually I just find the y coordinates first because that is by far the easiest thing to find. And so what I'm going to do here is notice that the 1/2 in the front is going to tell me what my y coordinates are going to be, and the fact that this is a tangent means it's going to go from low to high. And so I'm going to put here negative 1/2, positive 1/2, and I write that way just to remind my brain that I'm going to do the negative one first and then the positive one so that the graph is increasing. Okay, the next thing is the period. So the period would be pi divided by b, which in this case would be 1/4. And so remember that dividing by a fraction is the same thing as multiplying by its reciprocal. And so this is going to be 4 pi. That's going to make my x increment pretty easy because that will just be 4 pi divided by 4, which will be pi. And then finally, we want to find that first asymptote. So the fact that this is a tangent function means that I'm going to take my parentheses and set them equal to negative pi over 2 and then solve for x. And so there's a couple of different ways that you could solve this equation for x. You could leave all of the fractions there if you want to, or you could multiply by the greatest common denominator and get rid of all of the fractions. Either way is totally up to you. Personally, I don't like messing with fractions or thinking about them, and so I am going to multiply this entire equation by the least common denominator, which would be 4. That's going to be the number that kills all of these fractions. Notice that 2 would not be big enough because that would not cancel out a 4. And so when I multiply everything by 4, I'm going to get 1/4 times 4, which is just 1x, plus pi over 2 times 4 is 4 pi over 2, which reduces to 2 pi, and then negative 2 pi. Okay, so solving for x, subtract 2 pi from both sides. What you're going to end up with is negative 4 pi. And so negative 4 pi way on down here is going to be my starting x value. And then I am going to start counting by the x increment, which was pi. And so if I add pi, that's going to give me negative 3 pi. Add another pi, that's going to be negative 2 pi. Add another one, that's negative 1 pi. And then if I add one more to get my 5th point, that's going to be 0. Now, 5 points equals 1 period, but we're wanting to graph 2 periods. And so here, let's have just a quick chat about 0 right here. Not only is that going to be the end of the first period, it is also going to be the beginning of the second period. And so keep that in mind as you're counting out the number of points here. So the next one would be pi, and then 2 pi, and then 3 pi, and that's the 4th point of this period if you consider 0 to be the beginning. 1, 2, 3, 4. That means I need one more, which means my last x value is going to be 4 pi. Okay, so I'm ready now to graph my order of points for a tangent function, and so I'm going to start with an asymptote at negative 4 pi. So asymptote, and then low y coordinate, which I need to put that on the graph, so I'm going to put that here, negative 1/2 and positive 1/2, so make sure that you get that labeled. And then I'm going to put my low y coordinate, a 0, and then a high y coordinate, and then finish off with an asymptote there at 0. Now, that asymptote is not only the end of the first period, it's also the beginning asymptote of the second period. And so that means if that's the first asymptote, my next point's going to be a low y coordinate at pi. 2 pi is going to be a 0. 3 pi is going to be the high y coordinate. And then we're going to finish off with an asymptote there at 4 pi. And so as best you can, these are sometimes difficult to graph, as you're going to see on my answer key, but it's going to look something like that, kind of like a cubic function, if you will. Not exactly a cubic function, but very similar to it in a lot of ways, and so we're going to also have this other piece here, which, whoops, that is not very well done there. I'm going to try that again. This second piece would represent my second period. Okay, here on the second example, we have 4 cotangent of 2x minus pi. And so the first thing we want to do is figure out what our y coordinates are. And so that's just told to us by our lead coefficient, which is 4. And I'm going to write these in a very specific order, 4 and -4. And that's because on a cotangent graph, the high y coordinate is going to come first. Now, for the period, we know that to find that, we're going to do pi divided by b, which in this case is just going to be 2. And then the x increment is going to be pi divided by 2, which is our period, divided by 4. And so, again, dividing by a fraction is the same thing as multiplying by its reciprocal, and then you just multiply across and get pi over 8. Okay, and then we want to find the first asymptote. Now, this is going to be slightly different from example 1, because in example 1, we were graphing a tangent graph, and now we're graphing a cotangent graph. And so this means that we are going to have 2x minus pi and set that equal to 0. And so if I solve this for x, that means I'm going to add pi to the other side and then divide both sides by 2, and I get x is equal to pi over 2 as my first asymptote. And pi over 2 is going to be right here. I'm going to put it in the middle. And so there is pi over 2. Now, I'm going to start counting by my x increment. And because I want to do 2 periods, I'm going to do one of them by going to the right on the x-axis, and then the other one by going to the left. And so let's think about this for just a second. If this asymptote is at pi over 2, the next one is going to have to be 1 full period over from pi over 2. Well, if the period is pi over 2, then 1 full period over from pi over 2 is going to be 0. And so that might be just something helpful for you to figure out where the beginning of the period on the left is going to be, and then the period on the right will start at pi over 2. And so I'm going to count by pi over 8. I'm going to start at 0, and so that's going to be 1 pi over 8, 2 pi over 8, which will reduce to pi over 4, and 3 pi over 8. And so there's my 5 points for my first period. And now for the second period, I'm going to start at pi over 2 and keep going. And so I know that pi over 2 is 4 over 8. And so if I add another one, that's going to be 5 pi over 8, 6 pi over 8, which will reduce to 3/4, 7 pi over 8, and then finally 8 pi over 8, which will reduce to pi. Okay, so starting at my first x value, that was 0, I'm going to have a vertical asymptote, and then a low y coordinate, which I know is going to happen at -4, and my high y coordinate is going to happen at +4. And actually, this is a cotangent graph, so I misspoke there. This is actually going to be the high y coordinate first here at +4, then a 0 at pi over 4, and then the low y coordinate there at 3 pi over 8, and then this asymptote at pi over 2. But remember, that's the end of the first period and also the beginning of the second period. So now I'm just going to start all over. 5 pi over 8 is going to be a high y coordinate, 3 pi over 4 a 0, and 7 pi over 8 will be your low y coordinate, and you'll have another asymptote here at pi. And so this graph will decrease through that point there, through our 0, through our low y coordinate, like that, and then do the same thing on this particular part here as well. Okay, here on example 3, we've got y equals 4 tangent of x divided by 2, and so I'm going to start, as I usually do, by finding the y coordinates of a tangent graph, which means we're going to have the low y coordinate -4, and then the high y coordinate of +4. Next will be the period, so that will be pi divided by b. Now be careful with x over 2. Remember, we talked about this before, that x over 2 is really the same thing as 1/2 x. And so therefore b is 1/2. And so pi times the reciprocal of 1/2 is going to give you 2 pi. That's going to make the x increment then 2 pi, which is the period, divided by 4, or reducing, giving you pi over 2. And then you want to find the first asymptote. And so to find the first asymptote, we're going to take what's in the parentheses, which is x divided by 2, and set it equal to negative pi divided by 2. And so if you just multiply both sides of that equation by 2, that's going to cancel the 2 on both sides, and you're going to get x is equal to negative pi as your first asymptote. And so I'm going to put negative pi here, and then I am going to get ready and graph at least one period of this. I might just stop at one period. Hopefully you guys are understanding how you would get a second period, but I think I am going to just stop at one period in this particular example. So starting with the first point, negative pi, we're going to add our x increment, which is pi over 2. And so in order to do that, I know that this is over 1, and so these fractions have to be the same denominator, and so I'm going to multiply by 2 over 2. And so negative 2 pi plus 1 pi is going to equal to negative 1 pi over 2. And so that's where my next value will be. It gets a little easier from there, because if I add another pi over 2, that's going to give me 0. Add another pi over 2, that will give me pi over 2. And then another pi over 2 will be 2 pi over 2, which will result in pi. And so here at negative pi, I'm going to have my first asymptote. I need to go ahead and label my y-axis. I seem to be forgetting that a lot on these examples. Maybe next time I'll learn how to do them right when I find them. And what are we doing here? We're doing a tangent graph, which means we're going to start with a low y-coordinate, then a 0, and then a high y-coordinate, and finally at pi we will have our second asymptote. Now I'm going to erase this work down here just so that I can have enough space to go ahead and graph this. And so we're going to come up the asymptote here, through our low y-coordinate, through our 0, through our high y-coordinate, and then approach that other vertical asymptote. Okay, last problem here for tangent and cotangent. This is a cotangent function, and so the first thing we want to do is find our y-coordinates. We know that cotangent graphs fall or decrease, so we're going to start with the positive y-coordinate and then do the negative y-coordinate, and I'll go ahead and just plot those right now so that I don't forget later. Next thing would be the period. The period is going to be pi divided by b, which in this case is 1. Remember that b is that number in front of x, and so there is my period. Next thing would be the x increment. Take the period and divide by 4, and so pi over 4 will be what we use to count on the x-axis. And then finally the asymptote, which for a cotangent graph is found by taking the parentheses and setting them equal to 0. And so if we solve this for x, we're going to subtract pi over 2 on both sides and get negative pi over 2. And so negative pi over 2 is going to be my first x value. That's where my asymptote is going to be. That's where my period is going to begin. And so now, from that first asymptote, we are going to add our x increment, which in order to do that, we have to have the same denominator. And so therefore, we need to multiply this by 2 over 2. And so now negative 2 pi plus 1 pi is going to give me negative 1 pi divided by 4. And so negative pi over 4 is going to be here. Since my x increment's pi over 4, things are going to start to get easier now. That's going to be 0. And then the next one is going to be pi over 4. And then finally 2 pi over 4, which will reduce to pi over 2. And so now here at negative pi over 2, I'm going to have an asymptote. Start with a high y-coordinate, since this is cotangent, a 0, and then a low y-coordinate. And then finally at pi over 2, we will have our second asymptote, so that our graph looks something along the lines of this. It's not going to be perfect. These are somewhat difficult to draw, but there it is right there. Okay, if you guys have any questions on graphing tangent or cotangent, please reach out to me and ask, and I will be more than happy to assist you.